today we're going to talk about fractions. This is our next unit. And before we get started, I just want to go over a few of the learning targets that we're going to be looking at throughout the next 2 weeks. So our fraction learning targets are going to focus on finding fractional amounts and making comparisons, plotting fractions on a number line, using equivalent fractions to solve problems, comparing fractions using multiple methods, and of course we're going to continue to focus on the math practices. These will become strengths for you when you become a teacher of mathematics, and also they are excellent modeling tools. So we're going to be focusing again on practices 1, 3, and 6, which include making sense of problems and persevering in solving them. Attending to precision, I guess that's number 6, and 3 is constructing viable arguments and critiquing the reasoning of others. And that's where that justification piece comes in, when I ask you to justify your answers. Okay, so let's get going and start talking about fractions. First of all, if you are feeling like, oh no, here we are studying fractions, you're not alone. Fractions, for some reason, elicit fear in all kinds of people, and our students included. So please know that and expect that, and you can anticipate some difficulties that students are going to have with fractions. I'm going to talk about a few of those as we go through this. So first of all, fractions are simply a number that represents a part of a group. And so in this example here, you can see that we have 3/8 represented with this pie chart. The 3 represents the part. We call that upper part of the fraction, the numerator. And then the denominator, which is the lower part of the fraction, is representing the whole. So a fraction is just simply a part of a group or a part of a whole. In this case, it's 3 parts out of 8, which is the whole. So remember, it's part of something. And I accentuated the word of here because that's going to be something that we're going to focus on. So 3/8 of a pizza, part of a whole. 2/3 of a cup of sugar, part of a whole. 9/10 of a group, so it can also include something large, a quantity like a group. 9/10 of a group. So just remember about fractions that they are always defined in relation to a whole. Fractions are always in association with a whole. So keep that in mind and you'll be good to go. All right, so let's go on to talking about the improper fractions. And you can see here that I have a misconception alert, and that's what we see here. And remember that that simply is just to draw our attention that this is a place where students get confused. So for example, we see 3/2 here, and that's an improper fraction that we probably recognize. Students might say, that doesn't make sense. How can you have 3 parts of the whole, which is a smaller number, 2? And so before we make sense of this, let's make sense of just a whole number here. So think of 5 candy bars. 1, 2, 3, 4, 5. Think of 5 candy bars, though, as having 5 copies of 1 bar. So we have 5 copies of the same candy bar. So now with that same way of thinking, let's think of 3/2 of a bar. So if your candy bar is divided into 2 equal pieces, then we still have to have 3 copies. That's what our numerator is telling us. 3 copies of, here, a half. And so we have 1, 2, 3 copies of a half. And so that's one visual way to represent an improper fraction. And you're going to see when I look at number lines in a minute, another way to represent improper fractions. Just remember that the numerator is the number of that part, and the denominator is the size of the fractional part. Number of the part, size of the fractional part. In this case, you would have 5 parts. 5/6 would represent you having 5 parts, and then they are broken up into 6ths. That's the size of the fractional part, is 6ths. All right. So now we're going to talk about fractions as numbers. So often we refer to fractions as fractions of quantities, and in fact all the examples that I've given so far have been just that. We also want to talk about fractions as numbers themselves, just simply as a number that can be plotted on a number line, and that's what we're going to do. Look at fractions as themselves. So just think of a fraction a over b, where they're both whole numbers, and of course b cannot be equal to 0. A is just simply a number on a number line that is a over b units from 0. Just like any number on a number line is that many units away from 0, so is a fraction. And so if we look here, I have 0, 1, and 2 plotted. And of course this fractional world right here, you can see that this is one whole from 0 to 1. But I'm going to break that up into thirds, as you can see here. And now I can actually count on a number line in fractional parts. So I have 1/3, which is a fraction that can be written on a number line, and it's 1/3 of the distance from 0 to 1. 2/3 can be written on a number line, and it's 2/3 the distance from 0 to 1. You can also see then that I wrote 3/3 up here, and continuing that pattern by counting by thirds, 1/3, 2/3, 3/3, I go to 4/3, 5/3, 6/3. I can continue on. These are our improper fractions. So another way of looking at our improper fractions. Okay, next we're going to talk about how that relates to our decimal representation of fractions. And so just remember that when we represent decimals, we're just simply taking a divided by b. And so 5/6, that fraction represented as a decimal is just simply 5 divided by 6. You can think of the fraction bar here between 5 and 6 as a division symbol, 5 divided by 6. Or here, 5 divided by 6, if you want to think of it that way, in its decimal equivalent. So 2/7 is really 2 divided by 7, 2 divided by 7, and its decimal equivalent. So when we write a whole number in decimal notation, think about that for a second. If we write a whole number in decimal notation, there's only one way that we can do so without using a decimal point. With a decimal point, of course, we can continue to write that whole number forever. But without a decimal point, there's just simply one way. So look right here, like 47. There's no other way I can write that without a decimal point. But if we're talking about fractions, one of the cool things about fractions, in the case of fractions, it's infinite. And so I'm going to show you what I'm talking about right up here. And so in the case of the fraction a over b, we can continue to write equivalent fractions, and that's what we're going to focus on here, equivalent fractions forever. We could do this forever to infinity. So all we're doing is multiplying our numerator and our denominator by 2, and then we can multiply them by 3, we can multiply them by 4, by 5, by 6, and of course, forever. So here's an example. Let's take 1/2, and we're going to multiply both the numerator and the denominator by 2, and of course we get then 2/4, which we know is equivalent to 1/2. We're going to do the same thing by multiplying our numerator and our denominator by 3, and we get 3/6. Multiply the numerator and the denominator by 4, we get 4/8. And of course now you can probably see the pattern that we can continue this to infinity. So a visual way to look at this, I have a bar here that would be representing 3/4, so 3 parts out of the 4 are shaded. And so if we look back at this pattern where we take a over b and we're multiplying it by, any number, so let's just take 5. So we're going to multiply our numerator and our denominator both by 5. So then we have our 3/4, our 3 times 5, and our 4 times 5. So we're left with 15/20ths. So let's prove that visually. Let's show that. Let's justify that. So here we have our 3/4, but now we are splitting it up into fifths. So here, because we multiplied by 5, I'm breaking up each of those fourths here into fifths. So a fourth here, and I'm breaking those up into fifths. And when I do that, I can see that my 3/4 is now actually equal to all of those fifths, which include 15 of them. So there are 15 out of the 20 now, because now we have 20 fifths, which is the same as 3/4. So simply a over b, if you take a times any number and b times any number, so your numerator and your denominator times any number, you're going to get an equivalent fraction. So if the case is n is 7, that's the number you're going to choose. Then we just take our 3/4, multiply the numerator and the denominator both by 7, and we end up with 21/28, which is equivalent to 3/4. All right, next and lastly, we're going to talk about writing fractions in simplest form. And to do that, let's just remember that a over b is in simplest form if no other whole number, of course other than 1, can divide both a and b evenly. So we're going to use 18/24 as our example. So the first thing you should do is try to think of, and that's what we're doing here, think of the largest whole number that divides both 18 and 24. So to do that, you might want to make yourself a few notes here. And here I'm just factoring out 18 and 24. So when I factor out 18, I know my factors are 6 and 3, also 9 and 2, and of course 18 and 1. But I'm going to leave that one out because it has to be a number, of course, greater than 1. So I'm going to do the same thing with 24, and I factor it out, and I get 6 and 4, factors of 24. Of course, 8 and 3 as well, and 12 and 2. So now what I'm going to do is I'm going to circle all of the common factors. Well, I see 2 as a common factor, I see 3 as a common factor, and I see 6 as a common factor. Of course, I want to use the largest whole number, so I'm going to use 6. So since 6 is the largest, I'm going to divide both my numerator and my denominator by 6. 18 divided by 6 is 3, 24 divided by 6 is 4, so now I know that 18 24ths is equal to 3/4. Now I want to visually show that as well, using a picture diagram. And so what I have drawn here is just a bar with 18 24ths colored in. And so there are 24 little bars here. The blue represents the 18 out of the 24 that are colored in. And so if I'm going to divide by that 6, because that's the largest whole number that will divide both 18 and 24, then I'm going to count 1, 2, 3, 4, 5, 6 and divide my bar, and that's what that red line represents. So over 6, divide my bar. Over 6, divide my bar. Over 6, divide my bar. And now I have 3 sections out of 4, so I know that 3/18 is equivalent to, check it out, 3/4. All right. Thanks for watching this introduction to fractions. There will be another introduction to percents, which is also part of chapter 2, but I wanted to separate fractions from percents. So watch for that one coming up soon, and make sure that you see your instructor if you have questions.